So, hi everyone, welcome back. So, today I will be talking about Sri Lankan uh, biogeography. The title of the talk is Drivers of Sri Lankan Faunal Assembly, Faunal Exchange versus In situ Diversification. These are the two sort of contrasting scenarios that people have proposed, but turns out there's more to it, and hence I've added and more to the title. Um, by faunal exchange, of course, we mean faunal exchange between India and Sri Lanka. In situ diversification, I've talked about this in the past. Endemic radiations, where you have single colonization followed by a radiation. Um, Now, when we think of Sri Lanka, we often think of it as a small piece of landmass adjacent to India. So probably a lot of the flora and fauna of Sri Lanka is derived from India, and has a subset of the diversity that we find in India. Um, so that is what would come to one's mind. But turns out Sri Lanka actually has a pretty amazing biota, which is actually quite distinct in certain respects when compared to India. So this is what the talk is going to be about. I'm going to be talking chiefly on about fauna, not flora. Okay, so the point that often people have made is that Sri Lanka is part of the Indian plate, which drifted from Gondwana to Eurasia. So we'll come back to that. So Sri Lanka and India have shared a long geological past. So much of the flora and fauna of the two land masses are expected to be similar. But before we get into that, I have mentioned this before, that islands have long provided an exciting setting for evolutionary research. In fact, both Wallace and Darwin were deeply influenced by the peculiarities they observed on islands. And some of these observations provided the basis for their theory of evolution by natural selection. Darwin was, of course, very impressed by the Darwin's finches, by the Galapagos finches in the Galapagos Islands of South America, and Wallace did a lot of his work in Southeast Asia, in the Sunda Islands, Indonesia and Borneo and all that area. And what you see here is basically the island of Madagascar, which was, as you know, attached to India quite some time ago. Anyway, but before we get into the details, let's just quickly go over continental islands versus oceanic islands, right? Continental islands are part of a continental shelf or a tectonic plate, uh, and the way they come into being is that a large tectonic plate or a continental shelf breaks into smaller unit because of plate tectonic event, drift, and eventually this little part you know gets separated from the mainland and becomes an island. And if you think of a species that is distributed throughout this landmass, once it splits, the population isolated in the island then goes on to become a different species, evolve into a different species related to this species in the mainland. So one way that these continental islands come into being is actually continental drift. The other way is, if low-lying areas in a larger landmass gets flooded by seawater, um, we call it marine transgression event, thereby separating part of this larger landmass from the rest by a sea barrier, and eventually, elements on that island then speciate, and you have a new species. Now, Sri Lanka is an oceanic island because it is part of the Indian plate. It's sort of separated a bit from the Indian plate, and eventually the area between India and Sri Lanka was flooded with its seawater. Thereby, it became an island. So Sri Lanka is actually an continental island. Now, the other kind of island is the oceanic island. In case of oceanic island, from you know under the sea, from the sea floor, you have an island emerging, and this could be because of volcanic activity. So uh, this island is not part of a continental shelf, but because of volcanic activity in the sea floor, as volcano rises, you have an island emerging. Or you can also have coral reefs, sort of, in low-lying areas, coral reefs emerging above the surface of water, or basically coral reefs accumulating sand, and thereby a sort of an island sort of emerging above sea level. Uh, Now, these are oceanic islands. And typically, oceanic islands, when they first form, they are devoid of life forms. Uh, for example, if you have a volcanic island that has just emerged, obviously there'll be no life on it. Right? And slowly, species begin to colonize these islands. So much of the biota on oceanic island is due to dispersal, right? Whereas here, the process that causes speciation is allopatric speciation, and or we can call it vicariance, because a barrier separates uh, an ancestral population that had a much wider distribution, and eventually these populations diverge to give us separate species, right? So what we see in case of continental islands is a process called vicariance, which is basically allopatric speciation, whereas here we expect to see dispersals from the mainland and often radiation, right? And that's what the next slide talks about. So in case of oceanic islands, because they're devoid of life when they first emerge, uh, slowly species from the mainland begin to colonize, and because these are isolated islands, not many species make it, and the few lineages that do make it then undergo radiation, and these are called island radiations. And I've talked about endemic radiations in the past, and it's the same idea. The idea basically being that there are many open niches, a lineage makes it to the island, and then because there are all these open niches, it undergoes what we call a radiation. And when we build a phylogeny, all the species in the islands branch together, and they're nested within a larger phylogeny consisting of species from the mainland, right? So you see dispersal followed by endemic radiation or island radiation. Now, as I mentioned, Darwin was heavily influenced by what he saw in the Galapagos Islands, which are a bunch of islands off the coast of South America. And basically, he talks about the radiation of these birds. And today, using molecular data, we know that indeed the, the, the Galapagos finches, which are now called the Darwin's finches, are monophyletic. So there was a single colonization event from South America followed by a radiation, right? So this is oceanic islands. Okay. Islands are also interesting for a number of other reasons. One of them is island gigantism. Again, it is believed that because islands are isolated, often they do not harbor many of the large predators that mainland has. Also, many competitors are missing, so these few species that make it to the island tend to grow large, right? And here's a photograph of a water monitor. That I took this photograph actually in Sri Lanka, and I was just amazed by the size of this lizard. It's humongous. It's huge. This is like a crocodile, right? So you can see, for comparison, there are a couple of Dog macaques there, and this was, I think, taken in Polonnaruwa in northern Sri Lanka. And if you just compare the size, this animal is, from tip of the nose to the vent, you know, has like four monkey lengths, right? So the length of four monkeys, so that would be like that much, quite, I mean, at least a meter, and then if you add the tail, it's like more than 2 meters. So some of the largest uh, monitor lizard, monitors. Water monitors, I believe, are found throughout tropical Asia, but some of the largest water monitors are actually found in Sri Lanka. And interestingly, Sri Lanka does not have many of the large predators that India has. The only large predator that Sri Lanka has uh, is the leopard. Tigers are not there, lions are not there. Um, of course, there is fossil evidence of these creatures in the fossil records, but currently they aren't there. It also lacks many of the large herbivores. But anyway, so island gigantism is again something very, very interesting. I think it's worth looking into this in Sri Lanka. All right. Now, as I said, Sri Lanka is part of the Indian plate, and together with India, it was part of Gondwana, and then eventually Gondwana broke up. I've spoken a lot about this, and then the Indian plate collided with Eurasia about 55 million years ago, and eventually sutured with Asia 35 million years ago. So, Peninsular India and Sri Lanka share a long and common geological past and have been one geographical unit for most of their history, right? Together, they constitute Gondwanan fragment that separated from Madagascar 90 million years ago and merged with Asia about 35 million years ago. So they share a long geological history. So in fact, that's the Indian plate, and as you can see, Sri Lanka is part of this Indian plate, and that's 100 meters depth, right? And this is where you have the isthmus of the Park Strait, Gulf of Mannar, that separates India and Sri Lanka. Okay. Now, there have been many disconnections between India and Sri Lanka, right? The earliest, Sri Lanka actually began to separate from India. That actual tectonic separation, it is believed to have happened in late Jurassic, about 160 to 145 million years ago. And in the Oligocene, Oligocene would be 35 to 23 million years ago, I believe. Please check that. There was first connection between India and Sri Lanka. Since the collision of Indian plate with Asia, India and Sri Lanka first reconnected in the Oligocene, and then in early Miocene, 23 to 15 million years ago, Sri Lanka separated from India due to a marine transgression event, and the two land masses reconnected during Miocene-Pliocene boundary. That's about 5.5 million years ago. And in the Quaternary, that's about 2.5 to present, 2.5 million years to present, the land link was severed multiple times, and with the most recent separation occurring 10,000 years ago. So right now, Sri Lanka is again separated from India because of this shallow sea between India and Sri Lanka, and this most recent separation occurred 10,000 years ago. Right? So there have been many connections and disconnections between India and Sri Lanka. It was always connected to India for a long time, separates from India in the Jurassic, and then in the Oligocene 35 to 25 million years ago, there is reconnection. Then, in early Miocene, there's a separation again, and then late Miocene, Pliocene, about 5.5 million years ago, they reconnect, and then during the Pleistocene and late Pliocene, there have been many cases of connection and disconnection between India and Sri Lanka. And these most more recent connection and disconnections are because of Pleistocene glaciation, right? When there was the Pleistocene glaciation, sea level dropped, and this low-lying area emerged above and connecting India and Sri Lanka. Okay, so something else happened, and what is of relevance for us is from the Miocene onwards. If you go back to the Miocene, remember Miocene is 23 to 5.3 million years ago. Um, and But in in early Miocene, much of India and as well as Sri Lanka was covered in humid forests. But actually, if you go way back, in Eocene and Oligocene, there was global cooling and acidification. So this was a worldwide phenomenon, right? But in the mid Miocene, there was a humid period called the mid Miocene climatic optima between 26 to 15 million years ago. That is when those humid forests that covered much of India and Sri Lanka, and this was contiguous with humid forests in Southeast Asia, right? Now, from late Miocene onwards, acidification intensified, monsoon climate intensified, and in monsoon climate, you have a large dry period followed by a rainy season, whereas a more humid climate would have rainfall throughout the year. And this resulted in the dry zone being established, right? And the wet forest getting fragmented into small pockets in peninsular India and Sri Lanka. So this is in late Miocene, 11.6 million years onwards, right? So that's what happened here. Basically, these forests got cut off from the forests in Southeast Asia. So now, given this complex geological and climatic history of peninsular India and Sri Lanka, it would be interesting to ascertain how these events might have shaped current distribution of taxa on these land masses. What role has these events played in lineage diversification? So what are the events we are talking about? One is, periodic connection and disconnection between India and Sri Lanka because of rise and fall in sea level, and of course the acidification event that isolated the wet forests from those of Southeast Asia and from wet forests in India and Sri Lanka from each other. And the question that many people have been asking is, has Sri Lanka been a sink for species dispersal? Because Sri Lanka is sort of right at the end of peninsular India. Has it just received species from India, or has it also contributed species from India? And has much of Sri Lankan biota, is it derived from India, or other land masses have also contributed? So these are some interesting questions about Sri Lankan biogeography. In fact, Biswas and Pawar wrote an interesting paper, and the title of this talk actually comes from this paper. What are the drivers of islands' endemic fauna? Turns out Sri Lanka has a lot of endemic fauna. Is it faunal exchange between India and Sri Lanka, or is it in situ diversification? Remember, in situ diversification, island diversification, we tend to see in oceanic islands. But Sri Lanka is a continental island. Okay. A little more of background. This is the Oriental region or the Oriental realm of Wallace, of Alfred Wallace. And as you know, the Oriental region, also sometimes called the Indo-Malayan realm, is basically tropical Asia, right? It consists of India, Southeast Asia, and Wallace divided this Oriental region into Indian region, Indo-Chinese region. Indo-Chinese region is mainland Southeast Asia, and Indo-Malayan region, which is basically the Sunda region of Southeast Asia. This region is also called the Sunda Shelf. It consists of the islands of Sumatra and Java, as well as Borneo, Malayan Peninsula, Philippines. This whole landmass during the time when sea level was lower is basically one large island, right? So that's why it's called the Sunda Shelf. So basically, he divided, these the Oriental region into many sub-regions, and interestingly, he also combined Sri Lanka with the hills of southern India into another region, which he calls the Ceylonese region, right? So you have Ceylonese region, you have the Indian region, you have or sub-region, you have the Indo-Chinese sub-region, which is mainland Southeast Asia, and then you have the Sunda or the Indo-Malayan sub-region. So these are the four sub-regions that Wallace came up with, one of the earliest biogeographers. But this classification is interesting. This would mean that uh, so Wallace places Sri Lanka and hills of South India in the same biogeographic unit, while the remaining peninsular India is treated as a separate unit, right? So that would mean that the wetter parts of peninsular India and Sri Lanka form one biogeographic unit, right? So the wet zone of India. So remember, with the establishment of the dry zone, you have wet zone retreating to southwest India and Sri Lanka, and everything else is dry zone. So all of this is dry zone, only this part is wet zone in India and Sri Lanka. So Wallace's classification would then place elements or species from the Indian wet zone sister to everything from Sri Lanka. All species from Sri Lanka, both from dry and wet zone, right? And the Indian dry zone being distinct. Okay. So basically, if you take any group, sample it from all these different regions, the expectation based on Wallace's classification, if you build a phylogeny, the expectation would be that the species from the Indian wet zone would be sister to species from Sri Lankan dry as well as wet zone, and the Indian dry zone would be distinct from the rest. Right? Blandford, who was contemporaneous with Wallace, another biogeographer, basically says that the Sri Lankan wet zone species are more closely related to the Indian wet zone, and the dry zones of India and Sri Lanka are sister to each other, right? So that is the classification that Blandford came up with. Now, all of this was just based on traditional taxonomy, and then in the late 90s and early 2000, molecular phylogenetics played an important role in biogeography, and we call this area the historical biogeography. And this is one of the earliest paper that looked at the, the phylogeny of various groups that are found in India and Sri Lanka, and to try and understand how they are related to each other, right? Do we see separate clades in India and Sri Lanka? That would be, Blandford's scenario. No, I'm sorry, that's not Blandford's scenario. That could also be one of the scenarios. One separate clade in India, one separate clade in Sri Lanka. Blandford scenario is wet zone species from India and Sri Lanka branched together, dry zone species from India and Sri Lanka branched together. Okay, so what do we see? Here's an example of Lotus. Now, of course, so let me, the green lineages are all from Sri Lanka. The brown lineages are from India throughout for all these groups. So that is a frog, Philotus. Now the Indian group is called Raugestus, and Sri Lankan one Pseudophilotus. This is a Sicilian, an amphibian. This is shield tail, a snake, fish, shrimp, and freshwater crab. Now, what do we see here? Well, interestingly, we see separate radiations in India and Sri Lanka, right? But often the Sri Lankan radiation is nested with the larger phylogeny consisting of lineages from India, right? The same story here, right? Here again, well, here you see something of slightly different. The Indian ones are nested within Sri Lankan, but I suspect the sampling in India is not very comprehensive here. Here you see a back dispersal into India from Sri Lanka. You see the same over here. Um, so what we are seeing is radiations in India and Sri Lanka, right? But remember, Sri Lanka is a continental island. We expect to see radiations in oceanic islands. So Sri Lanka, in some way, has been behaving like like a oceanic island. Basically, that means it has experienced a lot of isolation. Okay, so 2004, early 2000s, in fact, many papers were published, and I'm not going to go over all of them. But the overall conclusions of some of these papers were that the Sri Lankan fauna is derived from an evolutionarily diverse Indian faunal stock. However, the phylogenetic tree also demonstrates that the overall limited biotic interchange has left both areas with unexpectedly large number of endemics. So you have radiations in India and Sri Lanka. The Sri Lankan, you know, clade is derived from India. Nevertheless, it is isolated. But there is some amount of movement between the two land masses in certain groups. uh, so a lot of this work is based on frogs. Yeah, the wet zones of peninsular India and Sri Lanka harbor ancient, unique lineages that have undergone independent radiation with very little interaction between them. So, in case of frogs, this is what you find. You have the red zone elements, especially in the frogs, completely separate, independent radiation, deep divergence between them. But the dry zone elements often seem to be very similar, right? But this part of the work has not been shown using genetic data, using phylogenetic tools. A lot of this has already been shown using phylogenetic tools, and that is, there are separate radiations in India and Sri Lanka, particularly in case of red zone elements. They are quite independent, deep divergence, and all that. So you have a radiation in Sri Lanka in case of red zone, in India, a deep divergence between them, and then the dry zone elements are more similar between India and Sri Lanka, right? But this part phylogenetically has not been shown much. But nowadays, some studies have actually shown that, and I'll just talk about one of them. Now, if you think about it, this is in a way not very surprising. This is a view of peninsular India and Sri Lanka, say from space. And you have the Western Ghats here, and you have the central highlands of Sri Lanka. And dashed line represents the wet zone. So west of that line is the wet zone. So you have monsoon winds blowing from west to east. Lot of rainfall along to the east, to the west of this ridge, and to the east of that ridge, it's all dry zone. And similarly in Sri Lanka, right? Now, if you look at this scenario, with the establishment of monsoon climate and with the edification of peninsular India and Sri Lanka, uh, the wet zone of India and Sri Lanka got isolated first, right? There was still a lot of connection and disconnection between Sri Lanka and India, um, and as the dry zone was established, the wet zones of India and Sri Lanka got isolated. There was still connection between India and Sri Lanka, and the dry zone elements could move about. right? So the isolation of the wet zone has been much longer, whereas the dry zone elements could move about because of rise and fall in sea level, right? So that's why the wet zone elements, you see greater isolation, greater evidence of in situ diversification in the two land masses, and much genetic distance between them. Okay, and we did some work on tarantulas of the genus Poecilotheria. There are about, I think, 13 species in India and Sri Lanka. And when we look at the phylogeny, what we really see is an India-Sri Lanka separation, right? So, but it's across the phylogeny. Okay, so if you look at this clade here, within this clade, you have one subclade confined to India, another subclade confined to Sri Lanka. So there's the India-Sri Lanka separation in both wet and dry zone, right? So you'll have wet zone elements, dry zone elements here, wet zone element, dry zone element here, and so on. And similarly, you have another clade here, which has the ancestral distribution of that clade is Sri Lanka, and there's another clade here which is India, right? So again, an India-Sri Lanka separation. In this case, interestingly, there have been two dispersal events into India. So you do have back dispersals from Sri Lanka into India. So Sri Lanka is not just a sink for species to disperse from India. In fact, it has also generated new lineages that have then dispersed into India. And then you have more recent dispersals in the dry zone between India and Sri Lanka. So the dry zone elements are actually quite similar, at least in this part of the phylogeny, because they show very little genetic divergence. This particular species is found in India, this one in Sri Lanka, and they are both found in dry zone, the northern dry zone of Sri Lanka, and the Rameshwaram coast in India. So there's very little distance between the two, geographic distance between the distributions of the two species. So there has been faunal exchange in the dry zone. Another interesting species from the Indian dry zone are the Sitana. If you look at Sitana, much of, in fact, 90%, 95% of the diversity is in India. And in Sri Lanka, there's one species found which was recently, in the past, it was classified in, it was called Sitana ponticeriana, but recently it was elevated to a new species called Sitana bahirae. But our species delimitation tools basically say it is ponticeriana. Morphologically also it is not terribly different. And this is all dry zone species. And if you look at the diversification in Sitana, much of the diversification happened after the onset of aridification. So remember, late Miocene, 11.6 million years onwards, there was intensification of aridification of Peninsular India and Sri Lanka, thereby isolating the wet zone. But the dry zone elements could keep moving between India and Sri Lanka because of periodic connection and disconnections between India and Sri Lanka. So this yellow part here represents the aridification event. So a lot of the diversification happened in Sitana during this aridification event. So within the dry zone, the Sri Lankan population is very, very similar to the Indian one. So it's basically ponticeriana. But sister to Sitana, by the way, Sarada was also called Sitana in the past. So it's another genus within this clade. But sister to this whole clade are the wet zone genus called Autocryptus. Now there's deep divergence between the Indian and Sri Lankan Autocryptus, right? So you see the same story as in case of some of the amphibians, particularly frogs, where there deep divergence between the wet zone elements. So these are confined to wet zone of Sri Lanka and India. So the dry zone elements very similar between India and Sri Lanka. The wet zone element exhibit deep divergence because that isolation has been much older. Okay, I'll talk about another group that we worked on, the Hemidactylus geckos. There's a radiation in India and Sri Lanka of Hemidactylus geckos, and this radiation consists of about 50 species. And we did some biogeographic analyses. Turns out there have been 7 independent dispersal events from India to Sri Lanka. So these are the 7 dispersal events. uh, 2 dispersal events occurred in early Miocene, leading to 2 endemic species. So those are the 2 endemic species in Sri Lanka, Depressus and Hunai, but you don't see an endemic radiation. You know, the other 5 were range expansions in species largely restricted to open semi-arid habitats and were likely to be more recent. Right? So out of the 7 dispersal event, the 2 earlier dispersal events resulted in these lineages evolving into distinct species. They are endemic to Sri Lanka. But the more recent dispersal events are largely range extensions. And these same species are also found in India, but they are all in the dry zone. So again, we see this dry zone elements sort of moving between India and Sri Lanka. Often it's the same species. Very little divergence between these 2 regions with respect to dry zone elements. Nemaspus, another gecko, interesting situation. 2 dispersals into Sri Lanka, right? So green here is India, that is Sri Lanka, that is Sri Lanka, that's all India. So 2 dispersals into Sri Lanka, uh, followed by endemic radiation, right? We don't see endemic radiation in case of Hemidactylus geckos, but in case of Nemaspus, we see endemic radiation. So this is very interesting. Why do we see radiation in one group of geckos but not in the other? So there is something worth exploring. Another interesting point here is this particular radiation of Nemaspus in Sri Lanka is sister to these 3 species from here, from part of the Sunda shelf, right? So there has been some faunal exchange between Sri Lanka and Sunda. So it looks like this lineage might have actually hopped from Sri Lanka to Sunda. And of course, the sister to all of them is from India. So looks like there was a dispersal from India to Sri Lanka, a radiation, and some of them then hopped to Sunda. I mean, this needs to be explored further. In case of Cyrtodactylus, another gecko species, a lot of work in my lab has been on geckos. We see something very interesting. This genus in India is found, throughout the Himalayas and in the northeast, and of course they are found throughout Southeast Asia, and then in Peninsular India and Sri Lanka also. The interesting thing is, Cyrtodactylus from Peninsular India and Sri Lanka are not related to the ones from the Himalayas or the northeast. They are actually more closely related to the ones from Southeast Asia, right? And that's what this phylogeny shows. This is the radiation from India, Sri Lanka. It is more closely related to elements from Southeast Asia rather than from Northeast India and the Himalayas. One would expect them to be more closely related. So this might have been a jump dispersal from the Sunda region or from maybe mainland Southeast Asia to either Peninsular India or to Sri Lanka, right? And then radiation. So, but one of the most interesting groups that shows some amazing faunal affiliation are the Sri Lankan agametes, right? In India, for example, we have Lotus, which is the typical example of a gamete. But if you look at the Sri Lankan gametes, especially these weird-looking gametes with amazing structures on their nose, they are actually sister to agametes from the Sunda shelf, right? Uh, uh, Borneo, Sumatra, Java, those islets. And they are not related to agametes from India, right? This particular group. You do have Calotus also in Sri Lanka, but this particular endemic lineage, endemic clade, is has a completely independent origin. It has come from the Sunda Shelf. If you look at another interesting group, skinks, uh, and in skinks, I'm going to be talking about subfamily Cincinnati, which is this whole clade here. And this group of skinks has, this clade of skinks has many limbless skinks. And if you look at this particular group, something very interesting we see, the Sri Lankan Cincines are not related to the Indian Cincines at all. In fact, they are related to the ones from Seychelles. Seychelles are these bunch of islands in the Indian Ocean that broke away from India while India was drifting towards Asia. So it's a Gondwanan fragment, small little fragment. And the Indian Cincines are related to a larger clade of skinks from Africa and Madagascar and Mauritius, right? So once again, the Sri Lankan Cincines have a very different evolutionary origin, and it looks like this has been a more recent dispersal, independent of anything in India, with respect to skinks of of subfamily Cincinnati. Okay, here's another example of the snake example of genus Cylindrophis. Now this genus exhibits what we call disjunct distribution. It's found in Sri Lanka, completely absent in the rest of India, and then you see them in Southeast Asia, mainland Southeast Asia, as well as Sunda. And the Sri Lankan Cylindrophis is sister to all these species. So again, a completely independent evolutionary history to that of. In fact, this genus is not even found in India. Right? Okay, there's one last interesting story here. The most recent time when I was in Sri Lanka, this was before the pandemic, I came across Hemiphyllodactylus in one of the coffee estates. We were staying in a cottage in a coffee estate. And I always thought that Hemiphyllodactylus was not found in Sri Lanka. The southernmost distribution of Hemiphyllodactylus was Peninsular India. So I was really surprised to say this. And then we spoke to one of the Sri Lankan herpetologists, and he said, look, this looks like it's a human-mediated introduction. I'm not sure if there's genetic evidence for that yet, but I think there's something worth exploring. By the way, typhus is commensal in a lot of other places, so it's quite likely that it is human mediated. In India, we have a Southeast Asian gecko genus called Gehaira mutilata, species called Gehaira mutilata, which is definitely an introduction into India. I think this is also found in Sri Lanka. So the faunal affiliation of Sri Lanka is quite interesting in that you have elements from India, and then there's isolation in the case of red zone elements. dry zone elements, lot of faunal exchange, and then you have lineages that are coming into Sri Lanka completely independent of India, and then in more recent times, I'm sure a lot of human mediated uh, uh, introductions into India, into Sri Lanka. All right, so here's the overall story. A large part of Sri Lankan uh, biota is derived from India. However, has been a lot of isolation also, endemic radiation, particularly in case of wet zone elements. And then you have independent uh, sort of colonization events independent of India from land masses pretty far away. In fact, if you look at the the flora of Sri Lanka, the wet zone of Sri Lanka, the lowline forests share many species with Southeast Asia. The higher elevation forests share species from the higher elevations of Western Ghats, right? The dry zone of Sri Lanka shares species with the dry zone of India, right? So the lower elevation forests actually have many species from Sunda shelf, right? So you begin to see similar kind of disparate uh, floral affiliation in this case, um, as with the faunal affiliations, right? So it's like they're related to groups from very, very different areas. All right. So to wrap it up, here's the emerging story with respect to the origin of Sri Lankan herpetofauna. Most of the examples I've given you are from squamates and frogs. That's why I'm just calling it herpetofauna here. The wet and dry zone elements of Sri Lanka are largely derived from India. However, wet zone of Peninsular India and Sri Lanka harbor ancient and unique lineages, some of which have undergone independent radiations with very little interaction between them. Dry zone elements are actually quite similar. Sometimes it's the same species or it's just sister species. Nevertheless, Sri Lanka also harbors lineages that have evolutionary origins completely independent of India. Right? So what we have is faunal exchange. Remember that there were some elements that also went into India from Sri Lanka. You have in situ diversification, especially in the wet zone elements, and then you have independent origin, right? Um, and if you look at the uh, faunal affiliation scenarios that people had proposed in the past, this story uh, or this scenario that Wallace proposed, there is not much evidence for this. This basically says that the Sri Lankan biota is nested within the Indian wet zone biota, which is not what we see. Blandford basically said wet zone elements of Sri Lanka and India are closely related, dry zone elements are closely related. There is some evidence for that, except that the wet zone elements are actually they are related, but they are also quite distinct in the sense that they have been isolated for a long time. They are endemic radiations in India and Sri Lanka. The dry zone elements are quite similar. There have been a lot of faunal exchange. Sometimes it's the same species. And then you also have India-Sri Lanka separation, right? You see that in Damascus, you see that in Tarantula. So wet zone and dry zone of Sri Lanka, there's one radiation. Wet zone, dry zone of India, there's another radiation. There are two separate clades in India and Sri Lanka. And then in case of agametes, you have a completely independent origin of some lineages of agametes in Sri Lanka from Southeast Asia, completely independent of India, right? So So that's what we are seeing with the herpetofauna. And if you go back to the question of, continental island versus oceanic island, even though Sri Lanka is a continental island, it exhibits uh, uh, patterns that one would observe in case of oceanic islands. A lot of endemic radiations. So it's just a fascinating place to explore some of these questions. Um, so what I've shown is mostly herpetofauna. It would be very interesting to look at a lot of other groups and see, what kind of patterns we will observe. Okay, I will wrap it up. That was about it. So I'll come up with more talks later. Thank you.